When we talk about the autonomic nervous system, which has two parts, we first address the sympathetic part, which is preparing the body to preserve itself. So it is going to have dilated pupil for far vision, heart rate is increased, and lots of activities result into consumption of energy, and even the person with increased sympathetic activity will have constricted strictures. Now we are going to address the opposite image, the parasympathetic part of the autonomic nervous system, and it is a state of rest, state of preserving energy. And we will go into the details in the next few slides. Person sitting on a toilet seat is in a state of increased parasympathetic activity. He is in rest. His pupil is constricted. That's why he is reading a newspaper. And his sphincters are relaxed. So he is in a state of preserving energy and a state of rest. Now, the theme of the parasympathetic nervous system is rest and digest. The autonomic nervous system has two components, and these two components are in balance, meaning that if one is increased, the other is going to decrease according to the needs of the body to preserve the body. When you look to the left of this figure, you can see the arrangement of the sympathetic system. A short axon of a neuron, which is called the preganglionic, then a ganglia near the first neuron, and then it has a long postganglionic axon to reach the target organ. And then when you switch to your right, you can see that it is the opposite. The axon of the first neuron is going to be a long one. Then the axon will meet a ganglion near the target organ, and the axon of this ganglion is going to be short. So both systems are two neuron systems, but they are different. What is the anatomy of the parasympathetic nervous system? It is a two neuron chain. The first is preganglionic neurons. They are located in the brainstem, and then the other part is in the sacral segment of the spinal cord, S2, S3, and S4. The postganglionic neurons, they are near the effector organs. Here is an image of three types of systems of parts of the nervous system. If you look at the upper one, you can see that a neuron sends an axon that is going to reach the target organ. That is the somatic type of physiology of the nervous system. If you go to B, the middle one, you can see that a neuron is sending an axon, and this axon is going to end in a ganglion, and this ganglion has another cell body which is going to send an axon to the target organ. Now this is the sympathetic type of circuits. If you go to C, you can find that the first neuron sends an axon that runs for a longer distance to meet a ganglion, and the ganglion will send an axon, short one, near the target organ. Here is a question: what are the target organs of the parasympathetic system? Pupils. When the pupils are affected by the parasympathetic system, they constrict. Sphincters, they are relaxed. The heart is beating at a slower rate. Glands secrete watery secretions. And smooth muscles in different organs. Like what? Smooth muscles of the gastrointestinal tract will be stimulated. Overstimulation results in diarrhea. But you have to be careful about smooth muscles of bronchioles. When these muscles are affected, they constrict. Therefore, cases of asthma get worse at night. What is this diagram showing me? Look to your right. It is the plan of parasympathetic system. And is it showing me where are the preganglionic neurons? The answer is yes. They are in the brain stem. What does the brain stem have? The brain stem has 4 parasympathetic nuclei. They are related to oculomotor, facial, glossopharyngeal, and vagus. And the preganglionic axons will be distributed along these nerves. Is this the only outflow of the parasympathetic system? The answer is no. There is the sacral outflow, where the sacral segments of the spinal cord have the preganglionic neurons, and they send their axons through spinal nerves to the ganglia near the target organs. So the parasympathetic system is craniosacral, and you know by now that the sympathetic is thoracolumbar. A summary of the parasympathetic outflow. Parasympathetic system has a cranial outflow and a sacral outflow. The cranial outflow is through the oculomotor nerve, facial nerve, glossopharyngeal nerve, and the vagus. The sacral outflow is coming out of S2, S3, and S4. One of the cranial outflow of the parasympathetic system is going through the oculomotor nerve. The oculomotor nerve has a parasympathetic nucleus, which is called Edinger-Westphal nucleus. Where is this nucleus? It is in the brain stem, particularly in the midbrain. Then parasympathetic axons will go along the oculomotor nerve and meet the ciliary ganglia. where is the ciliary ganglion? It is in the orbit. And then the postganglionic will go and supply the the iris. And this is the pathway of the first part of the cranial outflow. The second part of the cranial outflow is the facial nerve. The facial nerve has two nuclei, superior salivatory nucleus and lacrimatory nucleus. The superior salivatory nucleus is going to supply motor to the submandibular ganglion, and the submandibular ganglion will send postganglionic fibers to the sublingual salivary gland, submandibular, while the lacrimatory nucleus is going to send preganglionic fibers to the pterygopalatine ganglion, and this is going to supply the nasal glands and the lacrimal glands. Third part of the cranial outflow is through the glossopharyngeal nerve, cranial nerve number 9. And it is having a nucleus called inferior salivatory nucleus, which is going to send preganglionic fibers to the otic ganglion, and this is going to reach parotid gland. The fourth part of the cranial parasympathetic outflow is through the vagus, the most widely distributed cranial nerve, and the vagus has a nucleus called dorsal nucleus of the vagus, and it is going to reach multiple organs in the thorax and abdomen, and it is going to form plexuses like cardiac plexuses, pulmonary, myenteric in the intestine, mucosal in the intestine, hypogastric plexus for other abdominal organs, and renal plexuses. Now, the sacral outflow of the parasympathetic system is through spinal cord segments S2, S3, and S4. Preganglionic fibers will go through spinal nerves, and they will find the ganglion in the wall of pelvic organs. Visceral afferent, that is sensory, bringing pain from organs. Now, internal organs like heart, stomach, intestine, they will send pain impulses through the autonomic afferents, and these will enter the spinal cord segment through the spinal nerves, and then there is an overflow of impulses from the afferent parasympathetic. If the firing rate is very high, it will spill over to the somatic part, and then the ascending tracts will pick these impulses, and they will reach the brain. Parasympathetics to the heart is characterized by having plexuses, and these are around the arch of the aorta, and there are superficial cardiac plexus and deep cardiac plexus. If you look at this image, go to your left, which says parasympathetic stimulation to the muscles of the iris will result into constricted pupil, while the effect on your right is that of the sympathetic nervous system. Here is the plan of what happens to the pupil. When light hits the retina, then the optic nerve will pick up the impulses and it will send a branch, that's the optic nerve, it will send a branch to the pretactal nucleus. This pretactal nucleus is going to send a branch to the Edinger-Westphal nucleus, that is the parasympathetic nucleus of the oculomotor, and this is going to send preganglionic axons to the ciliary ganglion, which is present in the orbit, and the result is constricted pupil. There is a sympathetic wave coming from superior cervical ganglion that will join this pathway. Here is a simple diagram discussing the connection between the heart and the central nervous system through the autonomic part. First of all, the carotid sinus having baroreceptors. These impulses, they come through the afferents of the glossopharyngeal nerve. Then we have parasympathetic fibers bring pain from the heart to the vagus nucleus, and then the vagus also sends motor efferent fibers to the heart, plus of course the sympathetic effect, which is efferent on the sinoatrial node and atrioventricular node, plus the hormonal effect of the adrenal gland. This diagram is to be left for you to comment on it. Follow the lines, please, and note the labels. Another organ that is worthwhile looking at its nerve supply is the urinary bladder. The sympathetic part is coming from L2, and these postganglionic fibers will come and supply the muscular wall of the urinary bladder. Then we have a sympathetic nerve supply to the base of the urinary bladder, that is the trigone area, where it has the internal sphincter. So that's the sympathetic part. The parasympathetic part is coming from S2, S3, and S4. It is going to supply the muscular wall, where it increases excitability and affects contraction, and then it is going to supply also the internal sphincter, and then pudendal nerve, which is a somatic, is controlling the external urinary sphincter.